Welcome once again to our continuation of our lesson on Introduction to Database. Yesterday we covered, or in our previous lesson, we covered some ground where we were talking about the history of database, how they evolved to become what database management systems. We also defined some of the common terms that are used in the database management arena. I hope we have managed to grasp the concept that we talked about and the terms that we defined yesterday. So today we want to continue from where we left. We last looked at the limitations of database management systems. So today we want to look at the personnel involved in the database management system environment. Basically, we can group the personnel into 4 groups, which are database administrators, database designers, application developers, and end users. Let's look at the first group, database administrators. We can break them into 2, database administrators and data administrators, where the data administrator are now responsible for managing the data resources and providing the various definitions to the data that is stored in our database. So you realize as the database grows, the contents that it stores also grows. So sometimes you realize that for you to be a database administrator managing the technical side, that is the hardware side, the installations, the user rights and stuff like that, it might be too much work for you. Whereas you also need to look at the data side where you have some standards to manage, the data resources to manage, monitoring the data, all those things. So sometimes if resources permitting, these roles should be separated, where we have the data administration part having an individual responsible for that. Then we have the database part, the technical part, having an individual responsible for that. I realize most organizations think that this can be easily done by one person. Well, in my experience, I was once a database administrator, and I can tell you that with certainty, sometimes the work becomes overwhelming, where we are having hardware failures that we need to attend to. We are having also software challenges, data issues, data misrepresentation issues that you want to attend to, and all this is being centered on one person. While the management might think that the database administrator is responsible, it should be able to manage those things, sometimes it becomes very much overwhelming. Like in my instance, the database that I was managing was a web-based database where users would access the resource from various institutions. Now, sometimes on one day you'll be dealing with network connectivity issues, having challenges with network providers, the database is not showing in various locations. You have users complaining, we can't reach your resource, yet from your end you're reaching your resource. The next day, you are having some users telling you that the data is not coming out the way it is supposed to be coming out. So you realize that it becomes overwhelming. So separation of these 2 roles, the data administrator and the database administrator focusing on the technical side, that is the physical hardware, it makes it work a little bit manageable and easier. And also I think it also helps to improve even the functionality and performance of your database. So these are the roles that the database administrator will be expected to be executing, so that the data administrator will be expected to be executing. So in short, we can say this is the person who has a central responsibility for an organization's data. So his main responsibility focuses on what? On data. Then he leaves the physical side to what? To the database administrator. So the database administrator will manage the database infrastructure, monitor the database activity, manage the database management system, attend to issues to do with access rights, perform routine maintenance, backing up, testing backups, all those things. The database management system probably meant running the updates, tuning the system according to the updates that are coming in or according to the queries that are coming in from users, all those kind of things. And the next group we've got role of database designers. These ones usually come into play before the actual system is put into use. They sit with users, appreciate the user needs, then come up with real designs that solve what, or that meets the expectations of users. So they communicate with the prospective database users to understand what their requirements are. Then they come up with designs that meet those requirements. So these designers can be staff on the database administrator side that may be assigned various responsibilities in the design process. And they have to interact with various user groups that will be using the database. You realize as you are coming up or managing the databases, you have various user groups, and each user group has specific requirements that have to be satisfied or met by the database. Let's say you are developing a database for a telecommunication company. You have users at the end, the customers. You have users within the support staff of this organization. You have users in the supply side. So you have users in the management side. So you realize these users, you have different requirements or expectations from the database. And they require different views to be presented for them by the database. So it is these users that the designers will interact with before coming up with with a final design for the final designs, not design. There will be various designs satisfying various users. Then the next group of users that we have is application developers. So you realize that once the database has been developed and it's functional, and in some cases, as they are developing, there are specific applications that might need to be used or that might need to be designed for the database. So with these application developers, I know yesterday we mentioned about application programming interfaces that allows users or developers to come up with applications that can interface with the database using the APIs. So basically, on this group, we have three categories: system analysts. They determine the requirements of the users and develop specific applications to meet transaction requirements for users. Then we have application developers. They come up with specific programs. For example, yesterday I was giving an example of EcoCache where at one point they opened up their API that allowed users to design apps that could be uploaded on Google Store, and they will be able to interface with the EcoCache platform. So these application programmers, they come up with apps, with programs, with websites, all the systems they think can make interaction with with the database easier for users. And these groups of users, the system analysts and the application programs, they usually work behind the scenes. You rarely get to meet with them or interact with them. You only interact with their applications, and probably if they have a feedback platform where you give your feedback to the applications, that's how you mostly interact with them. Probably maybe another way you interact with system analysts and application programmers is when they are testing their applications. So they would want feedback from you. So if they don't test their application prior to it being launched, the feedback they might obtain it from the period you start using. But chances are You can't deploy an application without it having been tested. That would be suicidal. So during the test, they must select a group of users to test the application before it is what? Released for fully fledged use. Then we have end users. These are people like you and me who interact with the system without having an idea or without the need to know the detailed functionality of the system. What we just want is a functional system. Let's stick to our EcoNet, the EcoCache example. It's a mobile money transacting platform. What I want as a user is to be able to send and receive my money, to pay my bills using that platform. I'm not interested about who is managing the platform, where is he managing it from, on which platform is the system being hosted. All I'm interested in as a user, as a casual user, is to be able to pay my bills, to receive my money, to buy my airtime, all those kind of things. Then, of course, we have some sophisticated users who might need advanced functionalities of what? Of using the system, where they now need extra features that these casual users do not need. That's another group of users. Probably this will be a group of users within the organization. Let's say we're looking at the mobile money platform. We might need another group of users within the organization who are monitoring the system, monitoring the money movements, who is spending a lot on this platform, and what is the average spending rate on this platform of users. They now need advanced features to interact with those systems. Probably at the end of the day, this sophisticated group of users, they might need to assess the amount of money that is moved on the platform, the amount of airtime that is moved, the amount of bills that is moved. That is another group of users. The other two, I think you can go and read about them. So some of the points that I expect you to remember of the things that we've covered about so far, you should be able to articulate what are file-based systems, what are shared file-based systems, how did we come up with the database, what is a database management system, what are the roles of the various people involved in the management, development, and design of database management system, what are the benefits and limitations of of database management system. So I think these things, I don't think they will cause a lot of problems for you. So I expect you to recap as you are writing or we are reading, just be able to recite some of these things, so that when probably the difficult things comes, at least the easier things you'll be able to grasp. So let's look at the various types of database management system. We have quite a number of them. We have hierarchical databases, network databases, relational databases, object-oriented databases, graphs databases, ER model databases, document databases, and NoSQL databases. We will not look at all of them. I'll just pick a few to look at, and I'll pick those that will align to the things that we are going to look at in our course. Hierarchical database systems. That's our first one. Database management system that we're going to look at. So in these systems, I would equate them to a family setup where there are hierarchies in the family. You start with the great-grandfather, grandfather, father, going down. So this is almost a similar structure that is used in these database models, where data is stored in what? In hierarchies, which means a record will have a reference point to a record on a higher what? On a higher node. So information or records are stored what? Tied to higher nodes or tied to their parents. So to retrieve a field of data, we need to traverse through what? The hierarchy until we get to the node. So if you want to get any information about your son or about my son, it means I have to start with my great-grandfather, to my grandfather, to my father, to me, then what? To my son. That's how we will retrieve the record about what? My son. So it means there's a, I would say in government, they call it bureaucracy in access when you are using these hierarchical databases. Because they have to go through what? A lot of channels, which probably is a challenge on its own. It means even the speed of going to that record is a bit slower because it's not direct. And also another problem that then arises, I think, is the wastage of space. Because for you to access a record about my son, it means you have to have somewhere where the hierarchical information is stored, just to reference to a point where a record about my son is stored. So you are creating some extra or unnecessary files that contains pointers to what? To the son node. So already you are realizing there is some wastage of space. So I want you to go and write the advantages and disadvantages of what? Of these hierarchical database models. The next model that we want to look at is the network model. Now, in your fundamentals of information system, or is it data and IP, you must have done or looked at network topologies where you are looking at mesh networks, ring networks, something like that. When you are looking at a network model, it's more like a mesh network where each node of data is connected to a lot of other nodes. So which means from my son node, I can access, or from the grandfather node, I can access data directly to the son node. And from the son node, I can access data directly probably to his friend node without going through his hierarchy. Now, if we were on a son node, we want to access data about his family, we're going to transverse back to the grandfather of his family and go downward to the son. Now, with networked models, there are a lot of interconnections between nodes. And this brings us to a point where we will look about relationships between data items. You have one-to-one relationship, which was from the description that I gave, or from the example that I gave of the grandfather to son transversion. You realize that these are all one-to-one relationships. With network models, it's many-to-many it's one-to-many relationships or man-to-many relationship, where you have one node being related to what? To many nodes. So already, I think even the homework that I've given you relating to advantages and disadvantages of hierarchical models, we can already pick that another issue that you can explore. So when we are going to be doing normalization, I think the network models provides a very good testing or platform to test your skills relating to normalization, because it presents one-to-many and man-to-many relationships. But many of them are usually man-to-many relationships. And the examples of networked database management systems are the ones that I have listed there. So I want also to go and list the examples of hierarchical database management systems that you can come across in your research. The next model that we want to look at is relational database models. And one key thing that we can point or speak about when we talk about relational database management system is their reliance on the use of tables. When you talk about relational database systems, we are talking about data that is being represented in what? In tabular forms, columns and rows. That's what the key feature of what? Of relational database management system. Which means I expect you to appreciate and understand the concept of tables in databases. Because our course is focusing more on relational database module. So I expect you to have a thorough appreciation or understanding of of relational database system. Even the practical examples that we will throw around, they will be based on relational database management system. So remember earlier when we talked about some of the key definitions that we are supposed to be familiar with. A tuple, a row, an attribute, a column. I want you to go and relook at those definitions as they will become what? Your very good friends when you're dealing with relational database models, because you need to understand what a tuple is. What is a row? What is a field? What is a column? What does a column represent? What does a row represent? And one other key feature that is available in most relational database systems is query languages. We use what? Query languages to interact or to interface with relational database systems. That is, when you want to insert, delete, update, or access data or even create new records in a relational database management system, you use query languages. And the most popular of them all is what? SQL, structured query language. And we expect you to familiarize yourself with what? With this language, because we will use it and we will use it and use it. You cannot be a database administrator without an appreciation of what? Of structured query languages. So some of the popular RDBMS that are out there: MySQL, Oracle, SQL Server, SQLite. So I expect you to get one of these and install it on your machine, especially for our intent and purposes. We'll use MySQL. So find a way to what? To have it on your machine so that you explore and experiment with what? With MySQL. Probably if you can, or if you still have the practical assignment that we did previously in Fundamentals of Information System, where you installed some virtual machine, or maybe we'll just start a new practical assignment where I expect you to find an application that you can store as a local host so that we are able to what? To experiment with what? With this relational database management system using MySQL. So some of the major advantages that it's very easy to use, as you will see when we are going to do one or two practicals. Database entries can be modified without what? Tampering with the whole board, as was the case with what? With the hierarchical models. And like I highlighted earlier, that tables are what? A key feature of what? Of these RDBMS. So what are the properties of a table? The values are atomic. Each row what? Stand on its own with its contents. Its columns column values for different rows represent the same things. The sequence of row is insignificant, and each column also what? Has a common name. So you realize if the column is age, which means the data that is in the column should be what? Should be the same. If the row is, let's say, for a record, for like we gave the example for a son, let's say your son is John. If the row is for John, which means across all columns, the information contained should be what? Should be for John. That's why we say rows are what? They are standalone what? Records. You cannot have two information for two different records being stored in a single row. My apologies for the error there where I said rows, each row is alone. I will expect you to go and understand what do I mean by saying values are atomic. No SQL database. These ones I just put them here for interest's sake. They've been coming up of late, and I think they are becoming very, very popular. You don't need structured query languages to access or manipulate them. So because of that, and the variety of data types that you can store in them without complications, they are becoming very, very popular. And some of the popular NoSQL databases are the ones that I've listed there. So we won't dwell much on this, but I expect you to go and read a little bit about them so that you have an appreciation of what NoSQL databases are about. So go and read. Then you make your notes on the database models that I've listed there. So I've looked at 4 with you. So I expect you to look at the remaining 4. From the 8 that I listed here, we looked at 4 together. So go and write some notes relating to to object-oriented databases, graph databases, ER models, and document databases. These are just questions for try and recapture what we've talked about in this part where we're looking at introduction to databases. So thank you very much for your time and taking time to listen to this lecture. So if you are going to look at your syllabus, you realize we've covered section 4.1, which means we are left with about 3 sections of your syllabus. So before we go to section 4.2, I expect everyone to have written notes relating to the various assignments that I've assigned you to look at in these 2 lectures. Thank you very much for your time.